Let's take a look at some example video course. We will start with the bar test pattern generator, the one that we designed in hardware. We're just going to actually take it and design some wrapping circuits and insert it into the whole video systems that we have. So let's take a look at the code. So I'm starting with particularly this is the basically this is the hardware, which is the pixel generation circuit itself in here. So if you take a look at it, it's pretty much the same exact thing we've seen before. It takes some sort of an X and Y, basically a pixel location, and based on that, it will generate some sort of a color. Actually, 12-bit color, 12-bit color, 4-bit for the R, 4-bit for the green, 4-bit for the red. And if you take a look at it, it's exactly the same. It actually based on the location here. Basically, I'm dividing one region, second region, and third region, and based on the value of Y, I'll just basically generate different values for X and Y. This is almost exactly the same as when we designed it in hardware alone, except that here I have a little bit of an extra code in here. And what the extra code does is the following. So whenever these X and Y are generated by the global counter, for example, tells me I'm this particular pixel, okay, these X and Y will be actually available to me in the pixel generation circuit, and it will take, in this particular code or in this particular core, there's basically, it takes barely any time because it's just basically a combinational circuit here. If you think about it, I'm using an always comb. So it's a combinational circuit. I don't, like the clock in here is needed for something else, but it's a combinational circuit. So it's very, very quick. However, for the whole video subsystem, for the sake of consistency, because one of the cores will actually need a couple of clock cycles to generate its output from receiving the X and Y, what we will do is we will impose this particular restriction on all the cores. So whatever core you have, it will take the X and Y. It will actually take a couple of clock cycles to actually completely output its output. So this is what the assumption we're going to make, just because one of the cores needs it. Okay, so what you see in here is I'm basically taking the RGB and I'm just basically putting it through two registers, and this is just basically artificially I'm creating a two-stage delay, and that's about it. That's the only difference. Then now we have basically the pixel generation circuit is done. That's actually the hardware. I can't just take it and plug it into the system. I have to actually wrap it and create some sort of a wrapping circuit. So in this code in here, what I did is we're going to do actually the pixel generation circuit in here, which is that one here. We're just going to create an instance of it. So we're going to instantiate it, and then we're going to do some sort of a wrapping circuit. So let's take a look at the wrapping circuit. And remember, the wrapping circuit, similar to the MMIO, defines very standard signals at the inputs and outputs. So let's take a look at them. Of course, I need a clock and a reset. I need as inputs the X and Y from the global frame counter in here. And the standard video slot interface that we need is actually the chip select. The chip select is the one that basically tells me this is the core that the video controller decided that the processor wants to communicate with. Because remember, we have 8 of them, and usually they're connected to some sort of a decoder. Okay, and then there's the right signal, and which basically is distributed. The video controller just send this particular signal to all of the cores. There's the address, basically, so that we know which address internally in here, and we need 13-bit in this particular case. And there's the right data, which is 32-bit. And of course, these signals will allow me to connect it to the video controller at the top. But in addition to the video controller, I will have a stream input and a stream output. This basically are these two signals in here, one here and one in here. So if you take a look at the rest of the code, again, this is just an instantiation of the core itself, and this is where the wrapping circuit is. So before we actually design the wrapping circuit, what we did before is we figured out, at least in the MMIO controllers, like what do we want it to do? We had some sort of a register map. I'm not putting a register map in here because if you think about it, this particular circuit just generated this particular test pattern. So if a processor needs to change something, the only thing it needs to change is just basically either bypass it or not bypass it. Basically, do you want that stream, whatever input you put, to be routed to the output, or you actually want the pixel generation circuit to be the output? So the blender is not actually a blender. It's just basically a bypass multiplexer, and that's about it. And that's what you see in here. So what you see is the following. I'm basically creating some sort of a write enable. If you're writing and the chip select is selected that particular circuit, what we're doing is basically we're writing to a certain, basically we're taking the least significant bit of the write data, and we're just basically putting it in the bypass register. That bypass register typically is located, like if you remember, it's like it's at 0x2000, but we really don't, because we don't have any other things to actually write. The processor doesn't need to write to anything for this particular core, so we're just going to assume if it's writing to that particular location. So I don't need to use the address. But anyway, if you take a look at it, this one here is just basically a multiplexer that tells me, okay, is bypass register asserted? If it is asserted, basically you wanted to bypass that particular functionality. So the output will be exactly as the input. So basically your output, so the output in here will be exactly the input. You're basically routing that pixel stream here. Other than that, basically take the bar RGB, which is actually generated from here, and that's about it. And that's how you design this is how we actually took a picture generation circuit and we basically wrapped it with a wrapping circuit and we inserted it in the core. Of course, you're going to take this particular one here and just basically go and put it in the video system and basically just instantiate it and connect it through the other cores.